today in continuation with the applications of Gauss theorem. You know that already we have done about the electric field intensity due to a line charge. Today we are going to discuss electric field due to a uniformly charged infinite plane sheet. So electric field due to a uniform, that is uniformly charged infinite plane sheet. So this is very important application of the Gauss theorem. Now what is this application? That if you have been given a charge sheet like this, it's a charge sheet. If you see here, it is like this. It's a infinite charge sheet. That means infinite from up and down and from forward and backwards. So it's an infinite charge sheet. And you know, sigma is the charge density. What was sigma? It was Q by S, if you remember, surface charge density. In wire you used linear charge density. Now you have to calculate, say, the electric field at this point P. So what do? That you join this point P here. If you join this point P from this charge sheet, this is the line. Similarly, with the symmetrical, there will be another point on the other side, and this is, say, P dash, because both the sides, the electric field will go on both the sides away from the charge sheet. And then what you see that there is a line. So what you do, you will form a Gaussian cylinder on it like this. This is a Gaussian cylinder. Okay, so this is like something you have drawn, and this is like a Gaussian surface. So now you see this cross-sectional area. Where is the area vector? It is outward. Say this is S. This cross-sectional area is the area vector. This is outward S. Okay. Where is the electric field? Outward only. Where is the electric field? Outward only. Why? Because electric field will move out. They will not go up and down, but they will be on the perpendicular the surface charge sheet. So if I ask you flux phi1 from here, it will be ES cos 0. Okay. Flux from here, ES cos 0. So cos 0 is, you know that ES, it is also ES. So net electric flux, very easy. If you want to find out it, net electric flux will be phi 1 plus phi 2. So it will be 2 ES. Got it? The total electric flux is 2 ES. Now, as phi is what? Q by epsilon naught. So Q by epsilon naught equal to 2 ES. In place of Q, what you will write? Sigma S. So sigma S by what? Epsilon naught 2 ES. And then SS cancels out. Finally, you get E equal to sigma by 2 epsilon naught. So this is the electric field intensity due to the infinite plane sheet at any point, sigma by 2 epsilon naught. Remember, sigma by 2 epsilon naught. Got it or not? We'll take a point P here symmetrically on the other point, because both the lines are passing away from both the sides. So if the flux is ES, the flux is ES. Total is 2 ES. Q by Q will be sigma S. This will be sigma by 2 epsilon naught. So this is second application of Gauss theorem. Now the next one. If we see the next application is electric field intensity due to a uniformly charged thin spherical Okay, cell, this thin spherical cell, thin spherical cell. So we'll talk about this. What will be the electric field intensity due to a uniformly charged thin spherical cell? So we are going to take a spherical cell here. Say this is a charged spherical cell and there's a charge on it. Okay, it will have a radial symmetry like a point charge, and this is the center, and say the radius of the spherical is r. Again, what is sigma? All of you know, q by s. Sigma is surface charge density. So s here, we know it is 4 pi r square. Now what do? We take out the Gaussian surface. So we know that the Gaussian surface for this will be again the what? The outward. This will be the Gaussian surface. And there can be three cases. One is on the cell, outside the cell, and inside the cell. So say this distance is small r. And we all know that the electric field will be outward. Okay. So simply if I take 3 points, first is that when point P is outside the cell, okay, outside the cell, that is R is greater than R. So we know that here phi will be what? Q by epsilon naught. All of you know Gauss theorem. And then what is phi? EA. What is A? Is 4 pi r square Q by epsilon naught. So finally E will be 1 upon 4 pi epsilon naught Q by r square. You remember this? This is also for point charge. So E is simply 1 upon 4 pi epsilon naught Q by r square. If you want to replace this, you can do like this also, 1 upon 4 pi epsilon naught. In place of Q, you can write 4 pi capital R square sigma. So you can see it. It can also be written as sigma R square by epsilon naught R square. This is another form. This is for the point outside the cell. Now, if I ask you, second is that when point P is on the cell. Very easy, on the cell. Why? Because R equal to R. So E will be simply 1 upon 4 pi epsilon naught Q by R square. And if I put Q here again, sigma S, so 1 upon 4 pi epsilon naught. What is sigma S? Is that sigma 4 pi R square by R square. So this cancels out and simply sigma by epsilon naught. So on the cell, it will be this. And do you know, very interesting thing, inside the cell here, what will be the, so inside the cell we simply say it will be what? 0. So I'm writing here, it will be what? 0 inside the cell. So inside the cell is what? Inside the cell is what? E equal to 0. Why 0? No charge inside the cell. So there will be no application of Gauss theorem inside the cell. So simply 3 things we have calculated: outside the cell, inside the cell, and on the cell. Again repeating, you consider a Gaussian surface. This is the concept for the first one. This is the second one. Outside the cell is this. On the cell and inside the cell it is 0. Now I can draw a graph for this, and for this cell we can draw a graph. A graph is like this. You know that this is the graph, and say this is the cell. We have shown a cell on the graph, and this was the radius inside it. Electric field was 0, remember. and then you know that this graph goes like this. Very important graph. So this is between electric field and R. Here it was capital R outside the cell. So E is sigma by epsilon naught. E is 0 and E is what? 1 upon 4 pi epsilon naught Q by R square. So it is on the cell, it is inside the cell, got it? And it is outside the cell. So this is how we represent this graph. So I think you got it. This is the cell, this is the center, and this way we can represent the graph. So this is how electric field intensity behaves for a cell. Okay, now I have two questions here, very simple based on this. And what are the question? The first question is very simple. It is given a charge is given, okay, a charge of 17.7 into 10 to the power minus 4 coulomb is distributed. Okay, it is distributed over a large sheet. That means a large sheet is given. Area, say it is 200 meter square. 200 meters square, very large area. So calculate what the electric field intensity at 20 centimeter in air. Very simple. It's a formula based question. So how we are going to calculate it? We know that what is sigma, it is Q by S. So 17.7 into 10 to the power minus 4, S is 200. So we'll calculate it. If we calculate it, comes 8.85 into 10 to the power minus 6 coulomb per meter square. Then what is electric field? Directly we know the formula, sigma by 2 epsilon naught. We have calculated it right now. So it will be the value, we'll put it here of sigma and then 2. I think epsilon naught all of you know. Remember it, 8.85 into 10 to the power minus 12 permittivity in air medium. You calculate it. If you calculate it, it becomes 5 into 10 to the power 5 Newton per coulomb. You know that it will cancel out. So this is the answer for this numerical. And another numerical I can give you based on this only, and that is the related with the spherical conductor. So if I have a question is simple, a spherical conductor, okay, and that conductor is of radius, it has come in the board exam, it is of NCRT 12 centimeter and has a charge amount is given of 1.6 into 10 to the power minus 7 coulomb, and it is again distributed uniformly. Okay, so distributed uniformly over its surface. So over its surface it is distributed uniformly. And what is electric field? So electric field has been asked inside the sphere. Okay, inside the sphere. Second is what? Outside the sphere. Outside the sphere, but this is just outside the sphere. So just, it is written here, just outside the sphere. And the third is at a point 18 centimeter from the center. So this may be a 3-mark question from the center of the sphere. So this can be a 3-mark question. The solution is very simple. If you see it, what all of these questions are the formula based. You know that what has been given is the radius of that is given, I think 12 centimeter, 12 into 10 to the power minus 2, or you can write 0.12 meter. First is inside the sphere. I think all of you know inside the sphere what it will be, 0. Inside the sphere there is no charge, so E is 0, no charge. So we know that we can't apply Gauss law. And the second one, outside the sphere will be what? 1 upon 4 pi epsilon naught q by what? Exactly the r square. So we know 9 into 10 to the power 9. Q we know 1.6 into 10 to the power minus 7. And radius is what? 0.12. This is the radius, 0.12 square. So you calculate it, it becomes 10 to the power 5 Newton per Coulomb. And the third one is, that is at 18 centimeter. So 18 centimeter, you just change the radius. So again the same thing, 1 upon 4 pi epsilon naught q by r square. So 9 into 10 to the power 9. What is that? 1.6 into 10 to the power minus 7 upon 0.18 square. So you calculate it, it comes 4.44 into 10 to the power 4 Newton per Coulomb. So calculation you can do. So three things we see that inside there, on the, and this is given. So this is another numerical which has come in the board exam. So I can explain you two another examples related with the charge sheet, and very simple. One is that two charge sheets are given, like two infinite charge sheets are given like this. One is this, and another one is this. Okay, these are the two charge sheets given, and there are three regions. One is this, second region, and third region. And the question has been asked, find the electric field intensity in three regions. Okay, so we can find out it, and what has been given is that sigma 1 is the density of this, sigma 2 is this, sigma 1 is greater than sigma 2. So 3 points, and from this electric field is E1, and due to this it is E2. So first of all, this region, you see that the electric field goes away from the positive charge sheets, so away, so both will be in this direction, E1 and E2. And here also both will be in this direction, away from the positive charge, so E1 and E2. Now here it will be E first will be E1 plus E2, and here also E third it will be E1 plus E2. But in the case of the center, if you see at the center is very important. From this positive charge it will be away E1, but from this positive charge it will be in this direction E2. And here the second region is important, E1 will be greater. Why? Sigma 1 is greater than sigma 2, so it will be E1 minus E2. Okay. Now on the left side we take a sign convention. Sign convention is negative on the left side, so we know minus sigma 1 by 2 epsilon naught E1, and E2 will be also minus sigma 2 by 2 epsilon naught. So what comes in E1 is that minus sigma 1 plus sigma 2 by 2 epsilon naught. Got it? This is on the left side. So sign convention applies on the left side. If you come to this side, what will be E1 and E2 here? They will be what? In positive. So this can be written as sigma 2 by 2 epsilon naught. So simply you add them. So E1 plus E2, it becomes what? Sigma 1 plus sigma 2 by 2 epsilon naught. So this is which one? This is E third. So E third region is given like this. Got it? Now in the center E2 will be simply what? Sigma 1 minus sigma 2 by 2 epsilon naught. So this is E2, E1 and E3. So E1, E2, E3, three regions are given here, and you can calculate the electric field intensity in the three regions. But in the same question, if it is given that the densities are equal and opposite, the same question, if it comes like this, that one has a positive and the other one has negative, same infinite, okay, and this has sigma and this has minus sigma. So what will be in the three regions? Again, we have been asked on this first, second and third. If you see three regions, it will be simply what? Here in first region, it will be what? 0, and in third region also it will be what? 0. You apply it on the first given formula, and in E2, it will be sigma by epsilon naught. How 0? What was the first one? It was minus sigma 1 plus sigma 2. So sigma 1 is sigma and sigma 2 is minus sigma. So it was 0. And in E3, what it will be? It is plus sigma 1, sigma and sigma 2 is again minus sigma by 2 epsilon naught. So E third will be again what? 0. So here E first is 0, E third is 0. But when we talk about this E2, E2 is very important. E2 is what? Sigma 1 minus sigma 2. So sigma and sigma minus sigma plus sigma by 2 epsilon naught. So solve it out. It becomes sigma by epsilon naught. So this is the case for when the charge densities are equal and opposite. One is plus sigma and one is minus sigma. And finally, you know that there's a very important conclusion. One was like a positive charge plate, another was like a negative charge plate. One is having plus sigma, another is having minus sigma. Do you know this is a capacitor? As we end the content of this chapter, we get the concept of the capacitor, and electric field is sigma by epsilon naught. One with positive charge plate, another with negative charge plate. So this is how we say that this behave like a capacitor plate. So this can be the two cases which we can talk about, and I have one numerical. I can discuss that numerical also here right now. So what is the numerical? It has been asked in the board exam. It was in the paper also last year, and this question is of NCERT. And what is the question is that conducting what sphere of radius, it is 10 centimeter given, has a unknown charge. It has a unknown charge. That means you have to ask, you have been asked the charge, you have to calculate the charge, unknown charge. If electric field 20 centimeter, okay, 20 centimeter from the center of the sphere, from the center is 1.5 into 10 to the power 3 Newton per coulomb. Then, and it is radially outward, and radially not outward, it is given radially inward. Okay, so that means you know what does mean radially inward. Then the question is that find the charge on the sphere. You have to calculate the charge on the sphere. How we are going to calculate it? So radially inward it is. Solution is very simple. What is the electric field? 1 upon 4 pi epsilon naught q by r square. Very simple. This is the electric field. Okay. So q you can calculate it is 4 pi epsilon naught into r square. So I think 1 upon 9 into and E 9 into 10 to the power 9. Okay, the value R is what given and E is given. R is say at 20 centimeters has been asked, so 0.2 square, and then this is E 1.5 into 10 to the power 3. So calculate it, you get near about 6.67 into 10 to the power minus 9 coulomb, that is 6.67 nano coulomb. And do you know what is the sign of the charge? It will be minus 6.67 nano coulomb. Why? Because it is inward. Inward means negative charge is in that. Outward means positive, so radially inward. So this was the question asked in the board exam. It's a very important question in NCERT. And in this way, we have finished the content of the first chapter, electric charges and fields. So we'll continue with the second chapter later on, that is capacitance and potential. And thank you, and regularly watch my videos.